Today we are going to talk about sheet metal work. When you talk about sheet metal work, you see that sheet metal work basically is a special type of metal. Sometimes we have metals that we use in the workshops to be able to make some certain tools or certain materials that are normally required in workplaces. So sheet metal work is a process of bending, cutting or bracketing or forming special types of metals. And you realize we are almost done with the syllabus. I think what we have not done is the extraction. After we are done with the sheet metal work, the next thing that we'll be doing is extraction of metals. So I want people to be very keen. And I've realized that very many people are going to repeat this semester because the attendance has been very poor. But I know they'll know how to handle themselves. So sheet metal work basically is a special type of metal which is formed by industrial processes. This metal is generally formed in flat, thin pieces in metalworking. So the sheet metal is considered to be the most basic form. It's a very important thing that you need to learn as electrical engineers, because in very many cases you'll find yourself working in workshops and you'll be needed to do even practicals of dealing with these metals. So the metal is used to produce a wide range of objects that are required in the daily basis. Some major applications of this metal include the metal tables, the medical tables, bodies of automobile or trucks. You can realize that even when we are making, when bodies of the automobile are being manufactured or they're being made, they require very special metals. They don't just require any metal that can be used, but they need special formation of metals. So like trucks, roofs of buildings, airplanes, fuselages, based on the application on which they are used, the thickness of the sheet metal can vary. So they can come in coiled strips or flat pieces. Various tools are used to bend, cut. You remember we talked about bending, shearing, milling. We have talked about milling tools, how even to use the machines well, machines that can be used to bend, machines that can be used to cut. And we also talked about tools when we started our semester. We also talked about measuring and marking out of tools. Now we are almost in the final process of metals, and finally we'll finish with the extraction. How do we extract these metals? So tools used in cutting, bending, and shaping of the metal, of the sheet metal. There are four main types of tools required in the process of sheet metals. So these tools are explained below. So one of the tools or the major tools is the sheet metal bending tools. So you can now see an example of what is in the picture there. It is a sheet metal bending tools. As the name suggests, the sheet metal bending is a process in which the metal is bent by keeping its volume constant. So different types of equipment and tools are used for this purpose. There are some important tools and equipments used in these sheet metal processes. So as you can see, we have bench type of budget breakers. It's a wide bench top with a fixed lower beam. We will be looking at the pictures in another slide. So right now we are just defining the tools that are used to do the sheet metal work. Another one is the bracket makers. This is another type of equipment that is used for bending sheet metal. Bracket of various shapes and specification can be formed by bracket makers. So the 90% tool and radius tool of this equivalent are very helpful in the bracket formation. So the tools for sheet metal forming, the sheet metal forming process, we are also going to talk about the process in which the geometry of the sheet metals is altered by application of force. This force is sufficient to plastically deform the material by stressing the metal beyond its yield or strength. We'll also talk about these strengths, and we will also discuss about some other things. So the sheet metal forming tools, you can see another tool is here. This one is called a shrinker stretch. It is called a shrinker stretchers. This one is one of the most common sheet metal forming tools used today. The shrinker stretcher tool is used to form sheet metal without the need of heating, cutting, or welding. Smooth radius curves can be formed with the help of this tool. So the tool is mainly used to make inside curves. So to do this, the metal shrinking is done on one side. Another one is the sheet metal shearing tools. Shearing is just the process of cutting or the process of removing some part or cutting some straight lines on the metal. So shearing is the process in which the sheet metal is cut in straight line. Generally, this cutting process is used to make cuts that are parallel to the existing edges. So the process also allows to make angle cuts. We will also see how the processes are taking place. So we have types of shearing. We have throttless handle shears. These are the throttless handle shears features a heavy steel frame. As the name suggests, the tools has a throttless design. These tools allow you to cut effortlessly, meaning you don't need a lot of force to be able to cut or to be able to do the cutting of the sheet metal. Another one is the throttless rotary shears. So the rotary shears, these are tools. The tool is a bit more flexible than the hand shear. It allows you to cut any shape along with the forged sheet frame. So the throttless rotary shears feature an adjustable cutter and racketing head. So we are also going to talk about other tools like now the cutting tools. So you can now see the different types of material ranging from high carbon steel and ceramics and diamonds are used as cutting tools in the metal working industry. So the cutting tools are made from specific metals. They are not made from just any metal, but they have specific metals that can make the cutting tools. Now, as we have said, the metals like ceramics and diamonds are used to make the cutting tools. So it's important to know that the difference among each tool and its application in this modern era. So various tools manufacturing assign many names and numbers to the products. Though many of them appear similar, the applications may be entirely different. The most common error while selecting tools is calculating monetary savings based on the lowest cost per tool rather than on maximum productivity and extended tool life. So a machinist or an engineer must have information about, number one, the shape of starting the finished part. What is the shape of the finished part that you want to start? Another thing they have to be aware is also the hardness of the workpiece. How hard does the workpiece need to have? Like, for example, the hardness of a knife will not be the same as the hardness of a panga or the hardness of a saw. All of them vary depending on what the tool will be used to do. Another one is the tensile strength of the machine, materials abrasiveness, and power speed capacity of the cutting tools. So these are the ideal cutting tool metals must process the following characteristics. So you can see this picture. It contains some of these metals that are made from, some of the tools that are made from those quality materials used to make the cutting metals. The other characteristic that we should put into consideration in the cutting is the high temperature stability. They have to maintain high temperature, because if it is a cutting tool and maybe it is cutting a substance that is under high temperature, it should be able to sustain that temperature. Another one is the resistance against wear or tear. That is, the cutting tool should not be easily worn out, or you should not deteriorate at a short period of time, or it should not tear. Another one is the impact resistance, then a chemically inert to work material and cutting fluid. So no single cutting tool incorporates all these quantities. Instead, trade-offs offer among the various tools materials. So every new and evolving tool development has an application where it will provide a superior performance over others. So the optimum tools is not necessarily the least or the most expensive, and it's not always the same tool that was used for the job last time. So the general classification and application of each is listed below. We have the alligator shear, we have the abrasive saw, we have the band saw, we have the diamond saw. The alligator shear, also known as the crocodile or the liver shear, with the hinge jaw and powered by the flywheel. We will look at these pictures and how they work of the hydraulic cylinder. They are suited for cutting long metal stalks or crabs, generally where accuracy is not important. It is often used with large metal shredders. Another one is the abrasive saw. You realize that when we were talking about tools, we also talked about the abrasive saw, also known as the cut of saw or metal chop saw. It is specifically used to cut hard materials such as metals. And then the portable abrasive saws have made side jobs quite easier. Then we have the bandsaw, which are used blades. It uses blades consisting of continuous band of metals with teeth along one edge to cut various work pieces. So the band helps in uniform cutting as it has evenly distributed teeth on the load. Then we have the diamond saw. This one is a very hard saw that is used. It's a variety of diamond blades with circular diamond blades. Now, drills and surfaces, grinding wheels are used in construction work. So they are used in cutting stones, cobbled, asphalt, bricks, glass. So the diamond saw is a very important tool because it is mostly used in construction sites. Then the hacksaw is the normal saw that we need use for cutting for plumbers or electricians for cutting pipes and plastics. It's a very soft saw. The material is very light and can be easily used in cutting the plastics. So we have also the high speed steel. It is the subset of the tool steels and commonly used in tool bits and cutting tools. So it is often used in power saw blades and drill bits. They allow cutting faster than a high carbon steel. The main use of the high speed steel continues to be in the manufacture of various cutting tools, drill, stabs, milling cutters, tool bits, gear cutters, saw blades, and router bits. The jigsaw. What is a jigsaw? A tool used for cutting arbitrary curves such as the stenched designs or other custom shapes into the piece of wood, metal, or other materials. Another one is the milling cutters. All these are metal, the sheet metals, substances that are made from the sheet metal work. So these are cutting tools used in milling machines for machine centers performing milling operations. So they remove materials by their movement within the machine or directly from the cutter's shape. Another one is the bimetal bandsaw. Bimetal bandsaw, they are metal cutting blades used on the bandsaw to cut carbon sheets. So we have also carbon sheets, tool sheets, structural steel, stainless steel, pipes, and tubes. They can even cut ferrous and non-ferrous metals such as brass, aluminum, bronze, and steel. Tungsten, the tungsten carbide tipped. These are saw blades that are used for industrial use in cutting metals, aluminum, wood, or plastics. So the cutting edge consists of separate piece of material, either braced, welded, or clamped. So those are the types of sheet metal. So I'm bringing up another slide. So sheet metal working. What are the sheet metal working or the operations that we need to learn in this course? What are the operations that we need to learn? A series of operations that involve cutting, bending, and let me zoom so that you can see, and drawing of sheet metal sheets and sheet forming, that is 0.4 millimeters to 1/4 inch of the thickness. These are the advantages of the sheet metal. Now you can see the sheet metal working. The advantages is the cost is relatively low. They have good dimensional accuracy and good surface finishes and high strength. So there are various types or basic types of sheet metal operations. And as we have said, we have the bending, we have the cutting, bending, and drawing. So the cutting involves the process such as punching, shearing, and blanking. Bending involves the deforming of the sheet around the straight axis, and drawing involves the deform the sheet into convex and concave shapes. So those are the classification of the non-squeezing metal forming operations. We have the shearing is there, the bending under that, and the drawing and stretching. You can see under shearing, we have the simple shearing, the slitting, the piercing, and in your exams, you will be able to find some of these things, especially the neck exams. They normally give you application questions. They ask you like now in a question like now, the application of how the shearing, some of the processes or some of the outcomes of the processes of shearing or the bending or even the drawing. We also have under shearing, we have the piercing, the blanking, the fine blanking, the lacing, the notching, the nibbing, shaving, trimming, and cut off. And then we have in bending, we have the angle bending, roll bending, draw bending, and compressive bending, press bending, tube bending, the scanning, flanging, and straightening. Under drawing, we have the spining. Those are some of the processes or operations that take place in the metal forming. And then we have the spinning under drawing and stretching, shear forming or flow turning. We have the stretch forming, deep drawing and shallow drawing, rubber tool forming, sheet hydroforming, tube hydroforming, hot drawing and high energy rate forming, ironing, embossing, and superplastic sheet forming. And then the next one, now you can see the mechanical processes of the sheet metal processes. You realize that the sheet metal processes involve both mechanical and electrical processes. It involves the electrical processes in a way that it is the electric power that is used in the process, while the mechanical is the actual now cutting, bending, and shearing to bring that exact tool or the exact shape that is needed. You can see the mechanical properties of the sheet materials. When subjected to a tensile force, there are three deformations to be measured. That is the longitudinal strain in the width direction and the strain in the thick direction. Then the material is anisotropic. You have to make sure those are the characteristics of the materials that are to be formed. Now when shearing, look at now the pictures there. Now shearing of the sheet metal between two cutting edges. Just before the punch contacts work, punch begins to push into work, causing plastic deformation. So the punch compresses and penetrates into work, causing a smooth cut surface. So the fracture is initiated at the opposing cutting edge, which separates the sheet, that is forcing the shear operation. So you can now see the calculation of getting the force that is used in the shearing process is L, giving the total length to be sheared, and then T is the thickness. So the formula of the force to calculate the force, the total force that is used or the total force that is applied during this shearing is 0.5. That is a factor, that is a standard factor that is normally given over the UTS, that is the tensile, the unit tensile stress, and then times the T, which is the thickness, and then times the length, which is L, that is the total length that is to be measured. So the shearing that is a cutting metal operation, usually along the straight line between two cutting edges. Then the punch and blanking, you can see the punch and the shapes that are being done. Like now, these ones are different shapes that are used in our machines, or even in the tools that we normally use. Even when you look even at the maybe even the stoves that we use, even the tools that we use in the workshop, even at home, even the fabrications, like even the TVs, the metalworks, the stands, and everything, all of them need the metal working, that is the operation like now that the punching and the blanking. So punching and blanking are very similar in punching and cutting the piece in scrap, while in blanking the cut out piece is the desired product. So we can see how the products are being generated. This is the punching discarded. These are the discarded parts, the unwanted parts. And then now these are the part. You can see the notches and the perforation and the slitting. You can now see maybe the metalwork that has not been operated on. All of them are seen there. Then the next thing that we look at, that is now the punching being continued. You can see now the final product. Conventional, the sheared surface showing the distinct deformation and fractures, and bottom the magnified visual sheared edge. You can now see that edge. Characteristics of the die cut edges. You can see the characteristics and what it all involves about. The percentages. Yes, Simon, please mute your mic.
Okay, Mwalimu, I'm muting.
Okay. Then we continue with the characteristics of some of these products that are made from the sheet metal work. We have the rollover, that is the flow of materials around the punch, and the depth and clearance, the clearance and greater the roll over. Then we have the burnish, that is the rubbed or cut off portion of the edge. And then we have the fracture. This is the angled surface. These are now the you can see the whatever we are talking about is on this. You will be able to access the notes in the portal. You'll be able to look at these pictures correctly, clearly, and follow them. Then we have the bar, which are the very sharp projection caused by a dull cutting on the punch or die. And then we proceed. You can see still punching is there, and still the product. You can see now some of these products that are used maybe even in motor vehicles, machines, even several machines that we use comes out of the process of metal working. The clearance is defined as the distance between the punch cutting edge and the die cutting edge. So it depends on the hardness and the thickness of the material. As the thickness increases, the clearance must also increase. So the clearance typically values ranges from 4% to 8% of the thickness of the material. The recommended clearance is calculated where the clearance is C is the thickness, C is the clearance, T is the thickness, and the A is the alloy. And then the metal group now. These are the alloys of the metal groups. The aluminum alloy has between 1,100 to 52 aluminum alloys. Also can also be between 20, 24, and 60, 61. Sometimes when a calculation is brought to your examination, you will be able to be given these alloy figures. And now the die size determines the blank size, and the punch size determines the hole size. That is the D hole. That is the diameter of the hole. For a round blank, the diameter DB, that is for the blank, it is determined as the blank punch diameter, that is the DB, minus the 2C, which is the clearance. We said C is the clearance, and the blank die diameter D blank. So the round hole of piercing of the diameter DH is determined as the hole punch, that is diameter DH, that is the hole diameter is the DB plus 2C. So these are some of the small calculations that you will encounter when you'll be doing calculations, maybe when an exam is presented to you. So forces in punching operation. So if you want to get a force in punching operation, now the same formula that we use the other side is for the shearing. We will use is force is 0.7, which is a factor that we said that is normally given, times the tensile stress, times the T, and T, which is the thickness, and L, which is the length. Forming processes of sheet metals. So you can look at now the processes of forming. Sheet metals, due to its manufacturing process, is not an isotropic material. An isotropy is caused by the thermal processing of the sheet. Two types, namely a crystallographic anisotropy and the mechanical fibering. So an example is here of such a forming process. So local bond sheet exhibit an upper and lower yield strength. So as a result, during deformation, it shows stretched, strained bands. This can be eliminated by a reduction of thickness of maybe 0.5 to 1.5 by the cold rolling. So these are the ranges of the average normal the anisotropy that are used in various sheet metals. So you can see for zinc, it is given there for hot rolled sheet 8 to 1, for cold rolled rimmed sheet, for cold rimmed aluminum, copper, brass, and titanium for different types of metals. So an example again is there. This example, I like you to go and read them at your own time and be able to do the calculation. So in case of anything, I'll be able to explain them to you. So cutlery manufacturing, so we also have the sheet metal forming, also involves the manufacturing of the cutlery. Now the cutlery manufacture involves the blanking of the steel or stellaring silver on the proper shape. A rolling operation then gives the piece of the correct thickness. So after heat treatment and trimming, the piece has a pattern embossed on it in a stamping operation. Finally, the piece is buffed and polished. So you can see things like now the blanking is able to make now tools like now this, they are able to make tools like spoons, forks, and so many other things. And this one now you can see the polishing is done here, and then even the final piece is there. Okay. Now you can see the blanking is also there, the process of blanking. The blanking metals inside a closed contour in the desired part. You can now see how they are being, you normally have a surface that is already formed with patches, and then they can be able to form that shape or the shape of something that you need. So notching is also there. Notching edges or corners of the material is punched. So in notching, you have to make the edges of a material to be the exact size and shape that you need. The punching metal inside the contours is discarded, and the trimming is the cutting of or scrap, the cutting scrap or excess materials or a fully or partly shaped part. And then we have the shaving, that is the finishing operation of the previously cut edge by removing a minimum amount of material. Progressive stamping dies, you can see how they are generated. We have the common methods to handle the complex parts. And then we have the deep drawing. Now, as we talked about now the metal forming and the processes, metal forming processes. From blanking, we can go to the deep drawing, then redrawing, then ironing, doming, necking, and then seaming to be able to come up with products like this. So the process for the process of the 3D shapes, forming the 3D shapes of the sheet metal. We have the process of following from stage 1 all the way to 7. So step 1 is the blanking. You can see how it's done, as we had talked about. It involves the punch, the stock, and the die, where already shapes are made and diameters and measurements are done to be able to come out with special outfits. And then we have the deep drawing, you can see there. And then we have the redrawing, then we have the ironing, then the doming, and then the necking. The necking is almost the final stage, and then the seaming. Seaming is now the giving the final output of the product that is needed from the sheet metal work. Usually the cold working process, that is the punching forces and flat sheet metals on the piece of die activity. So the die cavity is usually circular or a rectangle. When the depth of the product is greater than its diameter, it is known as the deep drawing, and when the depth of the product is less than its diameter, it is known as the shallow drawing. So the sheet metal is supposed is supported on both sides of the blank holder in avoiding wrinkling. So it is, if the hold down press, that is the blank holder, forces it too high, then the sheet will tear, and if it is too low, it will rank. So these are the parts of the called working process. So you can see the punch is there, the blank holder force is there, the blank this is the blank holder force, and then the blank holder is there, the blank is there itself, the dies, and the drawing ring to be able to form our shapes and surfaces that we need from the metal forming processes. Okay, and then characteristics of metals important in the sheet forming processes. What are these characteristics of metals? These are very important parts. These are very important items in your course, because they will be able to most of the time you will be able to find them in your exams. You have to know the characteristics of metals before metal can undergo the processes of forming and anything else. You have to know these are metals, or you have to know the processes, the characteristics. One of the characteristics is elongation. What is elongation? Elongation, the importance of elongation determines the capability of the sheet metal to stretch without necking and failure. Necking is the bending, or the possibility of the end part of a tool or an output being deformed. So the high strain hardening exponent, that is an N, and the strain rate sensitivity exponent are desirable. And then another point is the yield point elongation, typically observed with the mild steel sheets, also called L, and hence a stretcher strain. And then we have the anisotropy, which exhibits a different behavior in different planar directions that is present in cold roll sheet because of the preferred orientation. And then another one is the residual stress, typically caused by non-uniform deformation during the forming process, that is results in part distortion when sectioned. Another one is the springback. The springback is due to the elastic recovery of the plastically deformed sheet after unloading. So the causes of distortion are part of loss of dimensional accuracy. So that is the springback. The properties of that metal should be able to spring back. And then the wrinkling, the causes caused by compressive stress in the plane of the sheet, and can be objectionable depending on its extent. Another one is the quality of the sheared edges. They have to have those characteristics, meaning depends on the process used. That is, the edge can be rough, not square, and contain cracks. So the residual stress and the work hardened layer, which are all detrimental in the formability of the sheet edges. And then we have finally the surface condition on the sheet. So you can see, let me save this. You can see this now, some of the outfits that are the deforming area, the failure deforming area. Now we have the blank holder when they are now separated, the bead, the support, and all the things that are need to be formed. So admission of the blank diameter. So the formula is given there. That is the pi d squared over 4. So it is calculated, and then it finally comes to the final diameter, that is the blanket diameter d naught, is equals to the root of the d squared, that is the distance squared, plus the 4 distance, the distance 1 times the height. Formability test. How do we test that the forming process is a success? The deformation in sheet materials are carried out by either stretching or by drawing. The ability of the sheet to withdraw large degrees of stretch or drawing deformation shape change without failure is known as formability. So the Erichsen test, that is the camping test, it is also called the camping test. a round punch is forced into the clamp sheet until a crack or a sudden drop force appears. So you can see how it is being forced in until it breaks that crack or it makes that shape that is needed. Another one is there forming a limit diagram. You can now see how the punch force has been punched in, or it has been forced in until it has made that diameter or the shape that is needed there. So those are other areas for the strain and anything. And then examples in calculation are there. That one is not that important for now. The limit drawing ratio, detection ratio. So it is defined as the ratio between the largest diameter of the blank that can be drawn into a specific punch diameter without failure. So the recommended drawing ratio are the following. That is for the first drawing, then for the second drawing, for the third drawing. The reduction, that is the value of reduction, should be less than 0.5 of the cylinder. The thickness ratio, the formulas are given here in case of any calculation, can be able to get them there. So an example is there that a diameter of the following is feasible if determine if the following is feasible for manufacturing. That is a cylinder cap inside the diameter of 3.0 and the height is 2.0 in its starting blanking size or ID is 5.5 inches, thickness is 3/32 inch. So how do we calculate the DR? That is it's a ratio. Then we get that is the ratio is the D blank over the D punch. That is the 5.5 which was given for the blank over 3.0 which was given for the punch. And then the answer will be 1.833 which is less than 2. And then the ratio now is the blank minus the D punch and the over the D blank, and then it can be calculated, and then the T blank, that is the thickness, is divided, and then you find the final answer as 0.017, which is less than 0.01. That is the drawing operation is feasible. Then an anisotropy ratio is there. It's also calculated. That is, there are two different types of anisotropy ratio, namely normal and planar anisotropy level ratio. The normal ratio is measured in the tensile specimen. It is the ratio between the true strain and the width direction of the true strain in the thickness direction. So the tensile specimen must confirm specific technical standards. That is, the longitudinal direction of the tensile specimen can be parallel or to a certain angle with respect to the rolling direction of the sheet. And then the planar ratio is there. It determines the variation of the true strain in the plane of the sheet, that is the rolling plane. So the value of the normal anisotropy ratio determines the limiting drawing ratio and the value. The calculations on the figures are also given there. So those are some of the common processes that are used in metal sheet forming. And the drawing and the bending now is Sorry for that. I had received a call. Sorry for that. Bending. Some sheets are bent along certain lines to produce a desired shape. So the bending introduces plastic deformation to a part, to the part, and it should remain in the desired shape, that is angle, after the load is released. So the springback is the part of the deformation. Yes, Isaac, please mute your mic. Good. So that recovers in plasticity, deformed material once the load has been released. So you can see now in bending, the original shape is here. It can either be bent in 90 degrees, it can be bent in 135 degrees, or depending on any of that, any degree or angle that is needed. So you can see vices or dices and punches. So this is a punch, as we had talked about the punching, and the dice. The dice is the one that holds in. So when a metal is put in between, it bends or it is punched depending on the angle, the specific angle of that punch. And the dice is also there to fit the exact angle that is in place. The bend allowance, that is the amount of deformation neutral axis of the sheet, depending on you can see that the bend allows the amount of deformation on neutral axis of the sheet depending on the bend and the bend angle. So the final deformation of the neutral, the final deformation or the dimension of the neutral axis and the bending area is used to calculate the blank length. So these are the calculations, though the calculations will, these for the bending will not always be needed in your calculation, in your exams. Then as far as the part is bended, the longitudinal dimension of the flat length is increased. So the allowance is the amount of material that is needed to be added to the flange dimension, in other, to develop the flat pattern. So you can see that how the bending is done. We have already talked about that bending. So the springback is also another bending procedure. That is, after releasing the pressure of the forming tool, the deformed work piece experience the dimensional change, that is the strain, due to the elastic recovery of the material. So the springback is found in all forming operations and more pronounced in bending. So it's as the yield strength, so the material increases as the modulus of the elastic material decreases and the springback deformation increases. So the springback is the ability of the material to come back to its shape. So the bending force, how do we calculate or go about the bending force? The bending load can be calculated, the bending load or force can be calculated from the following equation, where the unit tensile stress, that is the ultimate tensile strength of the material, L is the length of the blend part, and T is the thickness as usual, and W is the wideness, that is the width between the contact points. So a small formula is given there for calculating the force. The minimum bend radius there. The bending end of forming tubes. Those are as the different tubes. The stretch forming, you can see the stretch forming is now, when it is stretched, now this is on the outer part, that is the side, the dice is facing on the outer part, meaning a substance is stretched to come up or to produce a certain shape. You can now see the spining is there. Spining is there. That is the lower ideal, lower production volume, large parts, inexpensive tooling. You can see that. The roll bending, that is the large metal sheets and plates are formed into curved section using rolls. Roll forming. High energy rate forming is there. Electromagnetic forming. Electromagnetic forming is also another process that is very important. So the sheet metal is deformed by mechanical force of an electromagnetic field induced the next item that we are going to talk about is we are going to finish about the metal tools now that have been formed from the bending. So we are going for a break of at least 50 minutes for a discussion, and I'll expect people to be in the discussion. So we will come back and finish with the last slide after the discussion. So Grace, I'm seeing some of you maybe have network problems. So let people go to the discussion. I'm going to write it in the group. So we are going to be back here at exactly 10:10. Okay? So let us be able to go and join the discussion. Grace?
Yes.
It seems people are experiencing a lot of network challenges. Watu wanaingia wakitoka.
Mm.